Did you know that there are secret laws that engineers must abide by? A code that none of us can break. And no law is more sacred than the mighty Ohm's Law. Ohm's Law is a foundational part of engineering, and I can explain it all using a balloon. If you can believe it, balloons are actually a lot like batteries. We're all familiar with batteries. They give us power, and when they're out of juice, we either have to recharge them or put them in the battery grave. Now, batteries get their power by using energized electrons. But since we can't see the electrons in a battery, let's use this balloon as a proxy. When I blow a balloon up, it's like I'm recharging a battery. All of the air inside this balloon are the electrons I was talking about. Electrons are the tiny particles that carry electrical charge. When you charge something like your phone, you're actually feeding it electrons, like a Hungry Hungry Hippo game. Now that we have our fully charged balloon battery, we're ready to go. To understand Ohm's Law, you need to know 3 terms: voltage, current, and resistance. How do these terms relate to each other? Think of it like Mario Kart. Now, voltage is how hard you're pushing the pedal to the metal. Well, how hard you're pushing A to accelerate. Current is how fast your car actually goes. And resistance is everything that's slowing you down. Banana peels, bad terrain, falling off the edge, and of course, the dreaded blue shell. Now let's break this down further, starting with voltage. Voltage is the pressure that's pushing electrical current through your circuit. Now I know that sounds super abstract, but let's take a look at our balloon. All the air inside this balloon is dying to escape.
Let me out!
If I let go of this balloon even a little bit, the air's gonna rush out. Now let's say I blow it up more. Now there's even more air that wants to escape. This pressure is your voltage. It's the push that moves electrons through your circuit. Next up, we have current. That's the flow of charge in your circuit. It's how current gets from point A to point B. For a balloon, that's how much air is actually escaping. And it goes hand in hand with resistance, which is how we control that current. Let's visualize this. Balloon, it's time to meet Mr. Pinwheel. So right now, I'm holding this balloon completely closed. But if I loosen my grip just a little bit, watch what happens. We can see that air or current is leaving the balloon. Thanks for helping us visualize that, Mr. Pinwheel. Right now, my fingers are acting as a resistance, and the resistance is very high because I didn't let a lot of air come out. Since barely any current escaped, the pinwheel barely moved. But if I loosen my grip and lower the resistance, the pinwheel's gonna go a lot faster. Watch this. The current is more intense and the pinwheel is getting more electricity. Now that we understand the individual parts, let's bring it all together to truly understand Ohm's Law. Are you ready to meet the great and powerful Ohm? Well, behind the curtain, he's really not that scary. Ohm's Law is an equation that states that the voltage across a resistor is equal to the current through that same resistor times that resistor's resistance. AKA, voltage equals current times resistance, or V equals IR. That's it! It's a simple equation, but it's super important when you're designing circuits. It allows you to figure out what resistance you need to make your product work the exact way you need it to. Let's say we're designing a light and we want the light to be super bright, which means we want a lot of current. So we want a large I. But when there's more current, the battery's gonna lose its charge faster. Ohm's Law lets us find a middle ground where the light is very bright, but it also doesn't die in 2 seconds. Let's do an example. Here's a pro tip. For most LEDs, 5 milliamps is going to correspond to a lot of brightness in that light. Let's use Ohm's Law to determine the resistor that we need in order to create 5 milliamps in our light. So our NLAB has 5 volts, so V equals 5 volts, I equals 5 milliamps times R. So now let's solve for R. So R equals V over I, which equals 5 volts, divided by 5 milliamps, which is actually 0.005 amps, which equals 1,000 ohms, or 1 kiloohm. So now we know in order to make our light as bright as 5 milliamps, we just need to find a resistor in our kit that is 1,000 ohms. Congratulations! You've mastered Ohm's Law, and now you're a law-abiding engineer. And if you want to put Ohm's Law into practice, be sure to subscribe. We'll use Ohm's law to build real circuits. Until then, thanks for watching NLab.